Lighter than steel, tougher than carbon, with an unmatched ride quality, titanium bikes are seriously amazing. And that's why Litespeed has been committed to titanium since 1986. They even welded the frame and legs of the Curiosity rover that NASA sent to Mars. Now, I chose to order a Litespeed titanium gravel bike, and I could go on why I chose Litespeed, but I figured, why not show you instead? So I've come to the Litespeed Factory here in Chattanooga, Tennessee, to meet the people who are gonna bring my new bike to life. One thing that really attracted me to Litespeed is the, let's say, tube shapes.
Yeah.
Can you tell me a little bit about that?
Yeah, so the titanium that's used in the bike industry, its purpose.
Yeah.
It was created for aerospace use, hydraulic systems in aircraft. We bike guys got a hold of it ages ago and built a rust-proof, high durability, lightweight bicycle from it with really no tube manipulation. It was just kind of like using some scrap tubes that had been, overruns or whatever from aerospace use and crafted a bike from it. I think that's kind of where all good titanium brands start. And some stay within that space. They might do a little ovalization or a little fine touch for the mating of the tube joints where tube diameters may not meet up. I'm a little more focused, I'm a little more inspired by the folks that have created bicycle-specific tube sets, whether it be in steel, aluminum, carbon, whatever the case may be. I'm a little bit nerdy and obsessed with that perfect cycling-specific tube set that we craft here in titanium.
Tell me, what does it take to shape a tube?
So depending on the alloy and the starting material, if the starting material is tubular, we have the capability of drawing tubing. So it does come through a shaped die and we will form the entire length of it. We have the ability to taper tubing, whether that's reduce diameter, expand diameter, and then just general shaping with regards to ovalization. Because our draw dies, we're actually pulling triangular shape, 3-sided tubes, 4-sided tubes. At one point in time, we had a multifaceted 12-sided seat tube that a round clamp would still clamp onto, but we had enhanced that tube for what we were looking for in that era of bike design. So that's migrated and changed over the years, but we're very open-minded into creating tube sets specifically for the design that we look to create.
Cool. Can you show me where that happens?
Oh yeah, let's go. All right, so these things are pretty cool. The exaggerated shapes, because titanium has a lot of spring back. When you form it, you can expect that it's not going to hold the exact tool shape. Okay. So I have to over-calculate the form so that it springs back to the intended shape.
Do you figure this out through testing, or do you
just through experience? I've got some factors I can look at, certain geometry, knowing how much clearance I'm allowing on the virgin tube size, how much reduction I'm putting into the tube, and I'll have a really good idea based on corner radiuses and so forth as to how well it's going to hold that shape. And
but then so it goes through this and then it springs back to
springs back to something less or more.
Holy shit. Okay.
Yeah, I have to exaggerate the shapes.
That just blew my mind.
Yep.
I didn't realize that it did that.
There's a lot goes into tool design.
Okay.
Yeah, if you want a round tube, in one of our particular tapering operations, we don't make round tools. We have to form it at many different facets, many different degrees of interpolation. We ovalize it thousands of times to end result have a round tube because we're springing back. Wow. Yeah, it's really cool.
Okay.
Really. We had no one in aerospace doing these processes on titanium. Therefore, there's no manual written for it. We've written our own recipes on how we create tube forms.
Wild.
Yeah,
Okay.
it's cool.
And then this is the machine that does it?
So if we're gonna form the entire length of a tube, this is a in-house built draw bench. Draw benches are common in tube forming.
Okay.
Larger industries. We needed one for bicycle tubing. So I have the means of being able to push and pull a tube backwards or forwards through our die shapes. And that's a nice means of very, very systematically, very accurately forming shape into a tube.
Okay, wild.
Yep, yep. Some people will use a press operation for the more simple shapes. We do that as well, but the very technical forms, we want to draw those so that we're not only capturing the shape, but we're enhancing the properties of the tube and the material as we do so. That's what's very, very important, is that we enhance the properties, not reduce the properties, just for the sake of a visual.
Okay.
Yeah.
Great.
Yeah.
That's very cool.
Yep.
Can I see some like these like shaped tubes?
Yeah, let's go check it out.
Yeah.
All right, let's start at the head tube. Head tube looks really plain and boring.
Yeah.
If we go inside, one, our purge holes are milled to specific shapes. We're not just drilling a hole,
Okay.
you know, leaving an ugly burr. We're milling these shapes that are more appropriate to the tube that's joining it, and we're maximizing argon flow, the gas flow within the bike, so that our welds are more pure. Very, very important. This also helps with some of our new internal routing. So we were doing this long before full internal routing was a part of our menu, but our nice smooth edge holes that are shaped appropriately to the tubes that are joining, that's pretty cool. What I think is really an unsung feature is if you feel inside, feel the degree of wall thickness change and reduction.
Oh yeah. Okay.
Yeah.
There's like a really noticeable step there.
Yep.
Yeah.
Yep. So a huge amount of wall thickness change. And we've taken over 30% of this tube weight out just through standard double butting, but it's internally relieved. Some of our butted tubes, we're relieving that material from the outside prior to the shaping.
Okay.
Sometimes we come back and relieve material after shaping. So we have a great deal of capability based on what we're trying to achieve from a performance standpoint. Understanding the processes and how we can enhance a tube to perform in that bike is what's really, really cool and special about our shop. So top tube, you're looking at something that starts four-sided at the head tube. As it transitions, the four-sided stops about mid-tube, and then we're going to transition into a really nice oval. Now this is a pierced seat tube that also has joining seat stays. So the creation of this tube specifically for those two joints and forms that allow internal cable routing, that's pretty cool.
This seems like a really, this was formed using that die we're just looking at?
Yeah.
That's wild. And that it like changes right in the middle right there.
Yep. Now those were secondary processes that picked up, as well as the machining for the joint, so that we can essentially insert a seat tube, then join seat stays outside the normal trajectory into the seat tube, and have internal cable routing from top tube into seat stays. Really widens the joint, changes the feel of the bike, and we take all of that into consideration in our tube designs prior to welding.
And then so, can we see how these all come together into a frame now?
Absolutely.
All right.
Yeah. So the tube set that we were just looking at, Here it is as a tacked front triangle. It's all 325, super shaped. We've gone nuts on the shaping in this tube set. But we've also, what you really can't see, we've also gone pretty nuts in wall thickness control. So variation of wall thickness is part of the recipe of this bike. We control wall thicknesses and down tubes size by size. In our stock geometry bikes, these aren't just spec tubes that land in a certain size bike. We're very, very careful about wall thickness and weight control in the down tube of a small versus the down tube of an extra small versus the down tube of a large. So all of that varies very precisely. As we form and shape those tube sets, we go ahead and put the bottle holes into them, make provisions for internal cable routing. And then at this point, we were talking about the specialty machining where we're piercing for the seat tube and the joining of external seat stay joints. This is a great example of a bike pre-welding. We just tack welded this together. We've fully and completely welded the seat tube. Super, super important to have a great backbone of the bike that's fully welded, even where a weld may be hidden beneath another weld and a compound miter. We make sure it's fully welded prior to the next operation where the other tubes are joining.
Okay.
So, been in a lot of bike factories. I share a lot of passion with a lot of other builders. This is expected in a top-level hand-built bike. It doesn't happen in all frame shops. Typically, when you find a production frame shop, some of those finer details may go absent. Okay. So, something that we're adamant about, and it just creates more longevity to the bike. Other details in the tube set is from this model, we step into another that picks up a 6.4, 6% aluminum, 4% vanadium top tube, as opposed to the 3% aluminum, 2.5% vanadium alloy that we see in the complete front triangle of the prior bike, which is in seat tube, down tube, head tube of this bike. Reason for using the 6.4. We're looking to reduce weight, add stiffness. We do that through shape, alloy, and also by really beefing up this top tube area. I'm the guy that's got to balance out those performance factors and go to an even thinner spec in seat tube, or in the seat tube, down tube, head tube. Here you'll see the budding that we had internally on the past tube set has now gone external, and it covers a greater length. So where I may have reduced 30% in the prior tube, now we've reduced over 40% of weight. So pretty cool element that now comes to the outside surface, and you can visually appreciate the machining and material reduction that goes into.
This is something I've really liked about titanium too, is like I can see you doing it. You're like continuously refining it.
Yep.
Yeah.
Yep.
You don't like, the refinement like happens so fast.
Yeah.
And I don't know, the bike I'm looking at too has this wild top tube, the 6.4 top tube.
Yep.
This shaping, I've never seen a titanium bike with this sort of shaping.
Yeah. So that whole wider profile,
yeah,
we developed actually in the 325 alloy first. I had to raise the bar. We had to bring that methodology, that technology, we had to bring to our top level, and that's when the Spezia and Toscano on gravel came into our product range, is when we added those features. So it's a really nice system of features that we find really from the use, our customers' use. It's just a shared passion of where bikes have gone over, in my case, the past 35 years. And it's really cool to see where we are today and know where we're going for the future. So there's some things we won't see today, right?
And then, I don't know, I see these guys welding these frames up. This looks pretty wild to me.
Yeah.
Can you tell me about this?
Yeah, so this fixture is pretty special. It's one that allows optimum placement of the part for the welder. So on a fixed single rotation jig, sometimes it's tough to get around the undersides, over the top side. And this way, this fixture articulates, and the guy can put his weld joint right where he wants it for the comfort and positioning of his hands, the joint, and the purity of the weld. It's something we love here. Pretty cool tooling. We're all about function before fashion, so may not be the prettiest part around, but we love how it works.
We're going deep out of my knowledge base right now.
All right, so after welding, it's time for alignment and tolerance control.
Yeah.
We're going to make sure dropout spacing's perfect. Dropouts in accordance with the front triangle are dead center, on plane, paralleled, wheel clearance. We will have perfected seat tube bore, head tube bore, bottom bracket facing, all of the finer details.
Using that room back there?
Oh yeah.
Yeah, I noticed a lot of machines back there.
Yeah, we're making parts and the frame finishing operations where necessary.
Okay.
So it's a really unconventional use of a CNC machine shop, but it's really cool. Want to head back there?
Yeah, show me what, I don't even know what to look at.
All right, let's roll.
Yeah.
Shane!
I have visited bike building operations that are as big as this whole room.
Right.
And this is where you do all the machining.
Some of it.
Some of it.
Yeah.
Okay.
This is our CNC shop. We have another CNC capable we typically use for tooling, for building tools. This is really focused only on frame parts. It would be bottom brackets or the shells. This is these all
BB shells?
These are all going to be BB shells. Yep. So first operation on blanking and wall thickness control. Okay. We'll go through multiple operations. There's one that's closer to finished. Go inside, check that wall thickness.
Yeah, so there's a step on the outside, there's one on the inside too.
Check the weight.
Huh, impressive.
That's wild, right?
Yeah.
So we're buying a lot of material, we recycle a lot of material.
Yeah.
So it's very important to achieve the end goal. We're doing a considerable amount of machining here, and we recycle that as well. So pretty cool. So small parts, whether it be bottom bracket shells, binders, clamps, cable fittings, dropouts. We do a lot of work in here, but we also do some frame work in here.
Okay.
Because this is an unconventional place, as I'd mentioned before, to do some of the finer elements of bottom bracket work. Let's go look at it. This allows us to take all of that distortion out because we'll go through and re-ream the inside. We'll face the edges, and that way we create a perfectly parallel set of faces, a great interior bore, and then we choose whether we add threads to that or not. So it's a great capability, you know, to tie up a $100,000 piece of equipment just for that one operation. Seems a little crazy, but this guy has made a lot of great parts for us over the years, but at this point in time, I'd say about 70% of its time is spent on frames. So we can go back to, you know, we've got excess machining capability, but it's really cool to be able to use this machine in this way and have this resource. Not many frame builders have such a resource, and as you had mentioned, the room we're standing in, you essentially could build custom bikes in, but we're really fortunate to have CNC capabilities and keep them well maintained and using them in a lot of creative ways.
All right, what are we looking at?
It's time to get dirty. We're buffing the frames.
Okay.
A lot of deburring, taking off any sharp edges. We start the finishing process. When metal is welded, we do a really good job, internally and externally, of shielding with an inert gas so that oxygen doesn't impregnate the metal and we get oxygen embrittlement. Typically you'll see a lot of color in welds. Our welds stay very soft yellowy gold, and that straw color is a good indicator that we were very careful in the welding process. It's time to take that off of the tubes. That's what we call an alpha case. It looks cool. A lot of people want that raw welded look, but it's a thin skin. It will fracture, and that fracture could go deeper into the metal. So we choose to remove all of that from the frame, sort of an aerospace mindset that just yields better quality welded parts. And so that removal of the alpha case, and we start into really the hand touch and the hand finish that we send backwards and forwards here in our processing, because in this a bit more dirty area, we're also doing etching. So etch logos, the bike's gonna go down, get initial graphics application, and then comes back for some of the etching. And we keep all of the dusty environment processes really encased. It's for the cleanliness of the rest of our shop. You see the guys wearing masks and respirators here. They're just in there for a limited time. They rotate out into other jobs, come back in. So we're very health conscious with these processes. All right, so one of my favorite spots in the shop, and one of my favorite people, Andy. We've got great folks putting art onto our bikes, all brands, all models and whatnot. But let's go see what Andy's got lined up and what he's doing.
Okay.
Awesome. All right, so Andy, you're masking up for Shimano, right?
Yep, chameleon.
Right on. So all the different patterns, all the different color variations, all of that mastery is developed and happens with this guy right here.
Oh, I see. So this is being masked. So
Yep.
that
Yep.
Toscana logo is going to be anodized.
Yep. You'll see a lot of folks will put down big blotches of color.
Yeah.
Andy's worked with lots of different materials, lots of different methods. You know, and when they put a big blotch down, they're basically going to put a decal over it and then brush it off. And the edge quality is different than what Andy produces. The guy's got extreme discriminating standards and gets after it. How he wants to do it's how it gets done.
Yeah.
That's.
Can I get a bike finished like this?
If that's what you want, it can happen.
This is rad.
But this is off the charts. It's not on the menu, so you might, you know, you're special.
Gotta know the chef.
You gotta know the chef, right on. So kind of a blast from the past, a modern version of one of our legendary models. This is Gisalo. So this is prototype number 1 We've tracked every gram of this bike all the way through the process, every tube, every weld, every fitting. It's just a super cool one. And first piece is always got some things that we're gonna really critique about it. Second piece, we build them sometimes two at a time. In this case we did. Weight variance is inside of 10 grams. That's crazy and amazing for a welded bike. So our tolerance control in the tube set's been fantastic. And something there again within our capabilities that no one's seen from us in a while is a BSA 168 or a BSA 1375 by 24 68 millimeter bottom bracket shell. This one, we preserved that heritage. Many years ago I'd created a welded shell. So this is truly tubing in the center section, machined outer rings, and we went through the same CNC process. So the early Gisallos weren't built as precise as this one. They didn't go across a CNC machine for final bore reaming, threading, facing. We just took the old recipe and improved the process into a new bike. It's capable of modern tires. This is the rim brake version, so super cool.
Can I hold it?
Yeah, absolutely.
Holy sh!
When's the last time you held a metal bike that light?
That's wild.
Yeah.
Oh, these chainstays are crazy.
Yeah. Yeah, super fun, right?
That's like, that's shaping. It's like, it like flips here and then.
Yep.
Feel bad, I'm getting my fingerprints all over.
It's fine, dude. That's what this one's for. We're gonna get rowdy with it and make sure we like this recipe. We're gonna make some tuning and adjustment from here.
That feels, it's lighter than my carbon frame.
It is lighter than many carbon frames.
Yeah.
I never, even pretend to get in a light bike contest with carbon today, but this is titanium in modern standards. That will, and there will be a disc brake version as well. Fun. All right, so after all the graphics, all the tolerance control, we come to a build stand. End result, complete built bikes, going through further inspection, test rides, every bike gets ridden. Rain or shine, we're putting legs over these and making sure they're what our customers are going to enjoy the most. So a lot of fun to create these things and watch these guys put their expertise and their touch into each and every bike. It's pretty special.
Awesome. So these are the guys who are going to be potentially building my bike?
The Bruscano.
Yeah. So there you have it. In the hands of a few experts, titanium gets transformed into one of these beautiful bikes right here. Brad, thanks for showing me around the Litespeed Factory. I am super excited to have my next titanium gravel bike built by you and the Litespeed team. If you ever want to order a Litespeed for yourself, visit litespeed.com. And if you're ever in Chattanooga, Tennessee, pop by. Maybe Brad here can show you around.
Man, it's been great having you.
Thanks, Brad.
Cheers, buddy.